Alrighty, so in the next few videos, what we're going to be doing is we are going to be taking another look at the way the code generation is getting handled. Unfortunately, there were some issues with the way that I had implemented before, and those issues are preventing us from doing some stuff. Namely, it's preventing us from being able to unit test our code unless we were to do something like what we did before with the base, where we have our base project followed by our generated project, and do the same thing with the test, so that there'd be like a project for the tests components, a project for the generated code from the test components, and a project for the test project itself. And it's really starting to seem suboptimal. I'm personally not a big fan of the buzzmmo.base.generated project in the first place. It's kind of adding to our build times, adds to complexity, and adds just one more project in the ridiculously large amount of projects that we have going on here. So what I want to do is I wanted to come up with a different way of doing this that would allow us to have our components generated inside of the buzzmmo.base project. Now, there's a lot of issues with that, namely the way that I'm actually using reflection at the moment to write the generated code, if you recall, is by using a component map. And a component map, of course, is the object that we use to scan the app domain for our different component interfaces. Now, the problem is I can't inject code generation into buzzmmo.base that's dependent on buzzmmo.base already have been compiled, because then it would have to be recompiled or something ridiculous like that, and you just run into some really nasty issues. So the solution I came up with was I was just sitting down thinking, and I wanted to come up with something that not only would work here, but also allow me to add additional projects with additional components, and also be something that I can scale to different things in the future if I wanted to. And the solution I came up with was, why not just parse the C# itself? Why not actually come in here to the project, come into my components, systems, character select system, for example, parse out this code, find the interface, and use that to generate our code, and do this in the before step of the buzzmmo.base build. So before buzzmmo.base is even built, do the generation step, which would generate the valid generated code, and then when it got to the compile step, it would actually swallow up that generated code. Now, that might sound ridiculous to you guys, but you might not be aware of Microsoft's relatively new, this project's been around for like 4 years, project to open source and rewrite the C# and Visual Basic compilers. It's called Project Roslyn, and I think it's pretty close to being fully released. If I'm not mistaken, they're either in an RTM stage or a very, very late beta stage, and it's unlikely that their APIs are going to be changing much. Now, what's really cool about Roslyn is that it allows us to actually just use the bits and pieces of an actual very, very performant, standards compliant, built by Microsoft compiler, and use it in our own projects. And there's not a lot of instances where that might be useful, but in this case, that's going to do exactly what I needed to do. Now, we're going to run into some challenges, and one of the challenges in particular is that we are only going to be using the compiler, the parsing stage of the compiler. We're not going to be using the part of the compiler that actually understands what types are what and so on. If you're familiar with Antler, for example, where we're working with something that'll generate a parse tree, but it isn't going to make any effort to do any type checking or error checking on that parse tree. Now, the problem with that is you'll notice that when I do my generation here, inside generateCommands.cs, you'll notice that I do things like component.type.name, or in the case of my methods, I say component.type.fullname for the parameters, or parameter type.fullname, sorry. And we won't actually have access to the full name of something. We'll only have access to what the user typed. So what do I mean by that? Well, for example, let's say our character select system server ble method accepts a, I don't know, accepts a something that's in another namespace. So let's say some kind of object, hey. And then we have up here a using statement that says using buzzmmo, let's just pretend that some kind of object exists, dot something dot hey. So we're pretending that this class, some kind of object, is located within the something dot hey namespace. Now, this is problematic because while we're parsing the code, we'll only have access to what was typed by the user himself. So I employed a little trick that I'm going to use to make this work. I want to point out that even with the way that I set this up, it is still possible to confuse this method, but I think that the chances of that are incredibly unlikely, and I have strategies in mind to resolve a few of the potential issues that we might have if we ever come across them. But since they're so unlikely, I'm not going to worry about it. And I think the benefits of speed in particular, this will be, you might be saying, oh, you're compiling C# inside of a C# build phase. Well, actually, if you think about it, the performance is actually going to be pretty good, because all we're doing is we're using the parser. We're not actually building a build artifact, which makes it even more performant than what we have right here with our buzzmmo.base.generated project having to be actually built, turned into a DLL, and then linked to our other projects. So yeah, that's basically an overview of what we are going to be doing. In addition, there's other changes that I'm going to make. For example, inside of our current generated code, most of this is going to stay the same. In fact, there's going to be a lot of copying and pasting here. We're not going to have to rewrite even like 10% of the amount of code we've already written for the code generation. But some things I'm going to change is I'm going to change all of the class names to be random identifiers as opposed to actual class names that correspond to the name itself for the interface. And the other change that I'm going to make is going to be really interesting, because we have this component proxy factory, and I think the way that I wrote this was very short-sighted, because if we have multiple projects that have or expose components, how do we generate the code for that if both generated files, one in project A and one in project B, both have the exact same class called component proxy factory, located in the exact same namespace, buzzmmo base generated? See, that's going to be very, very problematic. It would, in fact, fail to compile. And not only that, you want to be able to, even if it did compile, you want to be able to know which proxy factor you're referring to. So what I'm going to do instead is I'm going to introduce the concept of a registry. So these component proxy factories are going to be broken up into what I call component registries, or proxy registries, or I can't remember the name of it. And they are going to be annotated with a particular attribute that's going to be picked up at runtime, and then we're going to loop over all the available registries and use them to register each one of the individual factory methods. And that will allow us to have multiple projects that have multiple bits of code generated on them, all kind of being squished together at runtime into one, cohesive glob thing, and giving us the most amount of flexibility. Okay, so what I'm going to be basically doing here is, I'll end this video before we start actually working on this, but the last bit that we're going to be doing here, besides the refactoring required in our client, our server, and our tests, is we're going to be changing the signature of our generate command. So instead of the generate command taking in generate component interfaces and then an output file path, instead what it's going to do is it's going to first accept a directory of which it's going to scan C# files. Now that's pretty cool, because since we're not compiling the whole thing, I can, for example, point it right here to this one components folder and say, just generate the components you find under this folder. And then that way it doesn't actually have to go out and parse all the rest of the C# code. Now, not saying that would be slow, but it's a really, really cheap improvement in performance that we can take advantage of. The next parameter is going to be a comma-separated list of what attribute is used to determine if an interface is a component. So as you see right here, for example, we have our components being annotated with the component interface attribute. But pretty soon here, what we're going to do is we're going to have that be able to be configured from the generate command, so that we can also generate things for example, our isolated end-to-end test right here, where we have our isolated component attribute. We want to be able to make that pretty flexible. And then finally, the last parameter of the component interface method is going to be the output file name. All right, so that's pretty much an overview of what we're going to be doing in the next couple of videos, or the next video, depending on how far we get. And I guess should go ahead and get started. And see you there.